Yeah, good evening everyone. Good evening. Good evening. Let's wait few more minutes until all the people will come. Good evening everyone. Good evening. Shikhar inform to everyone. Shikhar inform to everyone. Inform to everyone, Shikhar. Good evening everyone. Good evening Rinkan. Good evening everyone. Good evening. Just give that a few more minutes. Few more minutes give so that all the people will come. Give few more minutes so that all the people will come. Yeah, good evening everyone. Good evening. Good evening all of you. Good evening. Let's wait a few more minutes so that all the people will join. Let's wait a few more people. Just wait a few more minutes, all the people will join. Just give few more minutes. Right. Perfect. Perfect then. Perfect. Perfect then. Yeah. So perfect. So let me start this. Let me start this. I think everything is fine now. Let me start now. Yeah, I'm starting. Give me 1 minute. Give me 1 minute. Yeah, so let me. I think this is perfect. This is perfect. This is the perfect. So now let me go to the class. So those people who came today only, if you came now only, right? Those people who came just now, yesterday's class if you didn't attend, so after today's class over, you can go through it one time. Just I done here. See, I'm not done anything in the yesterday's class. In the yesterday's class, I done this. If anyone joined just now, if anyone started today only, if anyone started today only, I want to say to you, we started with the basics of graph. Right? Data structure subject, we started with the basics of graph. Graph basics we started. What is the graph definition? Combination of vertices and edges. See, every circle is a vertex. Every circle is a vertex. Right? Two vertices are right, connected by a one edge. Right? This is called edge. So vertices are here V1 to V4. Edges are going to be E1 to E5. Next one. So how many edges are connected to C? How many edges are associated to V4? I think V4 associated edges are E4, E2, E3. That is called degree. Number of edges associated with that vertex. That is called degree. Next one. Graphs are two types. Simple graph, multi-graph. When you say simple graph, right, self loop is not allowed. When you say simple graph, parallel edges are not allowed, like this. These are not allowed. Self loop is not allowed, parallel edges are not allowed. Whenever you say multi-graph, name itself saying multi means, right, some unnecessary things are allowed. Right, parallel edges may be allowed, or self loop also may be allowed, or operator. Any one possible, both are also possible. But remember, self loop will count degree by 2. Self loop will count degree by 2. Yesterday I already done. Those people who came newly, please take care. Next one. In n-vertex simple graph means no self loop, no parallel edges. In n-vertex simple graph, maximum degree of any vertex is n-1. See, if it is a simple graph, parallel, right? So I think self loop is not allowed, parallel edges also not allowed. So V1 is adjacent to other people. Adjacent means between two people edge there. Those two are adjacent. So V1 is adjacent to V2, V4, V3. So V1 degree is 3. So means one person can be adjacent to all other people. Other means n-1. So maximum degree of any person is n-1. So minimum degree of any person is 0. See, this person is not adjacent to anyone. He is not adjacent to anyone. Right? Minimum degree 0. Next one. In n-vertex multi-graph, maximum degree is infinite because there are so many parallel edges. Are there. So please try to understand. So minimum degree for the multi-graph of any vertex is 0. Here also same story. There may be one vertex, he may be not adjacent to anyone. This is what we discussed in the last class. If anyone having any objection till now, please let me know. Just I summarized once. Anyone having any objection, please let me know. Any objection? Anyone having any objection? So those people who came, if anyone came today only, my request to all the people, if you came today, nothing there after class over, right? Lecture number 1, you see one time. Make your own notes. Lecture number 1, you see one time, make your own notes. I will share these notes also. See, I will share these notes also. You also make your own notes. Now let's start. Because of everyone is comfortable. Now let me start. Write down everyone. So now our discussion is only simple graph. Write down. We are going to discuss now only simple graphs. We are going to discuss only simple graphs. Simple graph means, remember, no self loop, no parallel edges. That is called simple graph. We will discuss only simple graph. Now understand. Everyone try to understand. V1, V2, V3, V4. There are 4 vertices are there. Understand everyone. There are 4 vertices are there. Now how many people will go? Is it simple graph? I am expecting answer from everyone. Is it simple graph? Try to give answer. Everyone try to give answer. Not only coming and sitting. My request to all the people, please be active. Is it simple graph? See, remember, we will discuss only simple graphs. Is it simple graph? Yes. Why simple graph? Why it is a simple graph? Self loop is not there. Self loop means, right, loop to itself. So self loop is not there. And one more thing, if it is a simple graph, what is the maximum degree allowed to any vertex? Can you help me now? If it is a simple graph, maximum degree allowed to any vertex is, if at all 4 vertices, maximum degree allowed is 3. So now listen. So if at all a simple graph, 4 vertex simple graph, it is a 4 vertex simple graph. If it is a 4 vertex simple graph, maximum degree allowed to any person is, right, I think 4 vertices 3. Let us assume that to this person also I will keep maximum degree. Let us assume that to this person also I will keep maximum degree. Let us assume that to this person also I will keep maximum degree. So in the given graph, for every person, if you keep maximum degree, in the given graph, for every person, if you keep maximum degree, right, then that graph is called complete graph. Try to understand. In the given simple graph, for every person you kept maximum degree, then that graph is called complete graph. And one more thing, it is a complete graph with 4 vertices. Let me write now. 4 vertex complete graph. 4 vertex complete graph. People used to say that because of it is a complete, people may think that it is represented by C4. No, it is represented by K4. Complete graph with 4 vertices represented by K4. K4 means 4 vertices. K means complete. You may say that, sir, why not C4, sir? There is a one graph called cycle graph. So complete graph with 4 vertices, K4. Now let me ask, what is the meaning of complete graph? Every person in the given simple graph, every person having maximum degree. Some people are asking, sir, can you show K3? K3 means 3 vertices. When you say K3 means 3 vertices. K3 means 3 vertices. Whenever 3 vertices, maximum degree possible for every person is 2. For every person, give 2. Every person give 2. This is called 3 vertex complete graph. This is called 3 vertex complete graph. This is called as K3. This is called K3. Some people are asking, sir, what about K2, sir? What about K2? I think same. V1, V2. So 2 vertices. What is the maximum degree possible? 1 only. It is a K2. Right? It is a K2. Now last one. People are asking, sir, what about K5, sir? What about K5? Can you see this one? It is a V1. It is a V2. It is a V3. It is a V4. It is a V5. Totally 5 vertices. 5 vertices are there. Maximum degree possible is 4. Every person 4. Every person keep maximum degree. 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 This is K5. Complete graph with 5 vertices. Complete graph with 5 vertices. Let me know if anyone having any objection. Reddy sir, I am not getting this. Anyone having any objection, let me know. Anyone having any objection, please let me know. Reddy sir, I have this problem. Reddy sir, I have that problem. You let me know, I will help you. Simple graph with n vertices. That is called Kn. Simple graph with n vertices. That is called Kn. Simple graph with n vertices, which is the complete graph. Kn. Let me write now. N vertex. Simple graph. N vertex. Right? N vertex simple graph and complete also. N vertex simple graph and complete graph also. Which represented by Kn. N vertex simple graph and complete graph. Simple graph and complete graph, which is represented by Kn. Now, if you observe clearly, if everyone is okay with this, now I am going to give one formula. Everyone listen. So don't think more. Whatever going on, do justification. So currently what is going on is one topic is going on. See the current topic. No need to think more. This is the topic which we are going to discuss. It is the first topic of data structure. First topic of data structure is graph traversal, tree traversal. It is the first topic of data structure. Graph traversal, tree traversal. It is the first topic. BFT, DFT, that is the graph traversal. Pre-order, post-order, in-order, tree traversal. This is the first topic of the data structure. To this topic, the basics which are needed is basics of graph. When you say graph traversal, basics of graph required. So I explained little bit of basics. Still basics are going on. If anyone not attended yesterday's class, please go through it. Very less I covered because because I know that some more people, because of the new batch, some more people may join maybe tomorrow. Like that, I maybe go few classes maybe slow. Afterwards, we'll go fast. Today morning class algorithm, we are taken almost like 3 hours. Morning class algorithm, I taken the 3 hours class. This also same. After a few days, we will start the 3 hours class. Okay, fine. I think until now everyone is fine now. Now I understand. Very, very important one. Now understand. Can you help me now? When you say it is a 4 vertex complete graph, when you say it is a 4 vertex complete graph, everyone try to understand. Everyone try to understand. Please listen. Please try to understand this one. Careful. Degree of the first person, 3. Degree of the second person also 3. Degree of the third person also 3. Degree of the fourth person also 3. Can you help me one small line now? There are 4 vertices. Every vertex degree is 3. Check. There are 4 vertices. Every vertex degree is 3. 4 into 3. That means 3 plus 3 plus 3 plus 4 times. 4 into 3, which is 12. 12 is nothing but sum of degrees. This is nothing but 3 plus 3 plus 3 plus 3. There are 4 vertices. Every person degree is 3. So 4 into 3, sum of degrees. This is the sum of degrees. Sum of degrees are 4 into 3. And one more thing. Sum of degrees are 4 into 3. It's okay. Now listen. Whenever you say is degree 3, this is counted, this is counted, this is counted. Whenever you say is degree 3, this is counted, this is counted, this is counted. Remember, same person counted 2 times. Same edge counted 2 times. This person is also counting, this person also counting. So it is a sum of degrees because of same person counted 2 times, divide by 2. Then I think 12 by 2, which is going to be 6. 6 is nothing but, right, number of edges. If you want, you can check. It is the edge number E1, it is the edge number E2, it is the edge number E3, edge number E4, edge number E5, edge number E6. 6 edges are there. Now, if anyone is not getting, can you see here? There are 3 vertices. Every vertex degree is 2. There are 3 vertices. Every vertex degree is 2. So 3 into 2. There are 3 vertices. Every vertex degree is 2. 3 into 2. Remember, this is sum of degrees. 2 plus 2 plus 3 times. Right? Everyone now repetitive addition. 2 plus 2 plus 2. Repetitive addition is nothing but multiplication. So the 3 times, every time is 2. 3 into 2, 6. But the interesting thing is when you say 2, this is counted, this is counted. When you say 2 here, is also counted, is also. Same person counted twice, 2 by 2, which is going to be 3. If you want, you can check number of edges are 3. Edge E1, edge E2, edge E3. So number of edges in K3. Number of edges in K3. What is the answer? 3 into 2 by 2. Next one, in the similar way, number of edges in K4. Number of edges in K4. If anyone is not okay, nothing there. You can write in the comment section. I will take care. You just write in the comment section. I will take care. K4 is equal to 4 vertices. Every person degree 3. This is sum of degrees. Divide by 2. It will give number of edges, which is going to be 6. Similar way, can you help me now? 2 vertices, right? Number of edges in the K2. Number of edges in the K2 is equal to 2 vertices. Every vertex degree is 1. Right? So because of same edge counted 2 times, divide by 2 you do. 2 cancel 1. 1 edge only, check. In the similar way, there are, right, next one. Number of edges in K5 is equal to, there are 5 vertices. Every vertex degree is 4. 5 into 4 by 2. 20 by 2, so 10. If you want, you can check 10 edges are there. Now, what I mean to say finally, number of edges in Kn is equal to, there are n vertices. Every vertex degree is n minus 1, right? Divide by 2. Number of edges in the complete graph with n vertices is n into n minus 1 by 2. Anyone having any objection, please let me know. Anyone having any small objection also. Ready, sir, I am not getting. You ask me, I will help you. Number, right? N vertex simple graph and complete graph. Number of edges are n into n minus 1 by 2. What is that n minus 1? Maximum degree. What is that n? N vertices. N vertices where every person degree is n minus 1. Maximum, right? So, right, by 2. That is the answer for this. So the purpose of this one is in the simple graph with n vertices, everyone, if you want, I will write the note also. Can you see the note? Can you see the note? In n vertex, in n vertex simple graph, in n vertex simple graph, in n vertex simple graph and complete graph, and one more thing is complete graph. Otherwise you can write directly also, no need to write every time simple graph, because complete graph is simple graph only, you no need to write also. Let me write in n vertex complete graph. You can write like this also. In n vertex complete graph, number of edges is equal to n into n minus 1 by 2. This is the formula which is very, very useful to you. Please take care. In n vertex complete graph, number of edges is equal to n into n minus 1 by 2. Please take care. Any small doubt also there? Ready, sir? I have this doubt. You type in the comment section, I will help. You type in the comment section, I will help. Thank you, Himanshu. Thank you so much. Thank you so much. Thank you, Himanshu. Thank you. Thanks everyone. Now, if anyone having any objection, any small doubt also, please let me know. If anyone say, sir, I have some small doubt, you please let me know, I will help you. This is a very, very important one. N vertex simple graph, n vertex complete graph, right? Number of edges, how many? N into n minus 1 by 2. Now, one question I am going to ask. I don't know how many people will help. Now, one question I am going to ask. I don't know how many people will help. Please help everyone. In n vertex complete graph, number of edges are n into n minus 1 by 2. In n vertex complete graph, number of edges are n into n minus 1 by 2. Can you help me now? Is it maximum edges or minimum edges? In n vertex complete graph, number of edges are n into n minus 1 by 2. Is it maximum edges or minimum edges? I want to answer from everyone. In n vertex complete graph, number of edges are n into n minus 1 by 2. Is it maximum edges or minimum? How many people will give answer? Let's check. Everyone type. Is it maximum or minimum? In a n vertex complete graph, number of edges are n into n minus 1 by 2. Is it maximum or minimum? Everyone. Max or minimum? Your opinion, you write. Your opinion need not be right. Your opinion need not be correct also. Maybe right, maybe wrong. Please write your opinion. Is it maximum or minimum? Everyone. Maximum or minimum? Bro, please type. Everyone type. Bro, please everyone type. Sisso, please everyone type. Is it maximum or minimum? If anyone say it is a maximum, then what is minimum? In n vertex complete graph, number of edges are n into n minus 1 by 2. In n vertex complete graph, number of edges are n into n minus 1 by 2. If anyone say this is maximum, please let me know what is minimum. If you say it is maximum, what is minimum? If anyone says, sir, this is maximum, what is minimum? What is minimum? Can you help me now? Complete graph means any chance of minimum? Complete graph means any chance of minimum. Complete means complete. Complete means complete. Everywhere maximum edges. Everywhere maximum. Then how you get a minimum? When I say complete, maximum only will come. Because if I said complete graph, maximum also that only, minimum also that only, because it is a complete. It is already complete. Complete person. Maximum also that only, minimum also that only. Please be careful. Yeah, if they may blame you. See, they may blame you in the examination. In n-vertex complete graph, minimum edges how many? What is the answer? In the exam, they will blame you. In n-vertex complete graph, minimum edges how many? How many? In the exam, they will blame you. In a n-vertex complete graph, minimum edges how many? How many? To blame you. To blame you, they will give this question. N-vertex complete graph, minimum edges how many? Same. Maximum how many? Same. Sir, how can you say minimum, maximum same? It's a complete. It's a complete. It's a complete, yeah. It is a complete. It's a complete. Complete person is complete. How can you say complete person 0? How can you say complete person 0? What is the meaning of complete? Complete means full. Complete means full. Complete means full. Okay, fine. Now I think you got to know. What is the meaning of complete? Everywhere maximum degree. If you keep everywhere maximum degree, how you will get the minimum? Because of everywhere maximum, there is no chance of getting minimum. What is the meaning? Maximum also that only, minimum also that only. Maximum also that only, minimum also the. To trap you, they will ask this question. In n-vertex complete graph, minimum edges how many? So I think some people are there, some kids are there. Right? Kids will think like this one. N-vertex complete graph, maximum. Complete means maximum, na? So n into n minus 1 by 2. Everywhere keep maximum, maximum, maximum. But kids will do like this one. N-vertex complete graph, minimum. Minimum, na? 0, 0, 0, 0, 0, 0. Array, buffoon. Array, buffoon. It is a complete. How you keep everywhere 0, 0, 0? Some people are there, some doubtful people. N-vertex complete graph, minimum. Minimum means minimum degree 0, na? 0, 0, 0, 0, 0, 0. If you keep everywhere 0, 0, 0, 0, then how it is complete graph? If everywhere if you keep 0, 0, 0, 0, 0, then how it is a complete graph, yeah? If you like 0 that much, keep your son name 0. You like 0 that much, keep your son name 0. Abhishek, if you like the 0 that much, keep your son name 0. Let us assume that after 5 years you will marry, keep your son name 0. Because you like 0, na? You like 0, keep everywhere 0, 0, 0, 0, 0, 0. If you like 0 that much, keep your son name 0. Suppose if you get the data, if you get the data, small 0, right? Daughter small 0, maybe son big 0. Keep like this. Some people will think like this one. In n-vertex complete graph, maximum. Okay, maximum. Everywhere keep maximum. N into n minus 1 by 2. In n-vertex complete graph, minimum. Everywhere keep minimum. Array, gootlay. It is a complete graph. How will you keep everywhere 0, 0, 0, 0? How will you keep everywhere 0, 0, 0? Yeah. After exam is over, n-vertex complete graph, what is the minimum number of edges? After exam is over, array complete, na? I written 0, 0, 0. After exam is over, it is complete. Complete means everywhere n minus 1, na? N into n minus 1 by 2. Ayyo Rama. After exam is over, people will say Ayyo Rama, Ayyo Sita. If you say Ayyo Rama, Ayyo Sita, right? BJP people will come. Marks will not come. Ayyo Rama, Ayyo Sita. After exam is over, if you say Ayyo Rama, Ayyo Sita, BJP people will come. Amit Shah will come. Modi ji will come. How marks will come? Are you getting? How marks will come here? After exam is over, Ayyo. Array, it's a complete, na? How I written 0, 0, 0? Ayyo. Right? I will say one story also. See this one. This year GATE exam. See this one. There are two friends are there. This year GATE exam, 2025 GATE examination. There are two friends are there. One friend name is Arman. right? One more person name is, one is Arman. One more friend name is, one more friend name is, right? I think Ashwini Sharma. One more friend name is Ashwini Sharma. They both are the in the EPT in one of the batch. I think batch number I think 13. In the batch number 13, Arman also there, Ashwini also there. Ashwini Sharma. Arman also there, Ashwini Sharma also there, right? So they both are, right? They both are the same batch. Like how you are attending, they are also attending. Now in the GATE examination, they both are roommates also. In the GATE examination, what happened is, right? He got approximately, Arman got approximately 66 marks. Approximately 66. Ashwini got approximately 63. Ashwini got approximately 63. Arman got 66. So his rank became Arman rank became approximately 500. Approximately 500. Ashwini rank became 1300. But difference is only one question. Only one question. One question or two question. Right? I think it is a 66. It may be 64. It may be 64. One question is the difference. One question only difference. One question only difference. Small mistake he done the small mistake. He will go to IIT. We don't know about this person. He will go to IIT because of 500 rank. We have approximately 15 IITs are there. He will go to IIT. Pakka he will go to IIT, but I don't know about this person. Right? I don't know what is that. See the one more interesting answer. There is a one more person. His name is Rahul. There is a one more person. His name is Rahul. He got 69 marks. I think 68 or 69. Plus or minus 1, forget about. I think one more question difference. One more question difference. His rank became 300. His rank became 300. One question only difference. Is IIT? See this one. Top 5 IITs confirmed. Top 3 IITs. 3 IITs or 4 IITs. Top 4 IITs is confirmed. Is the top 7 IITs confirmed? Top 7 or top 10, whatever it may be. Here some dilemma there. Small difference. One mark, one question also there is a difference. One question also there is a difference. Please do practice properly. One question only difference. One question only. One question only. Whenever one question is wrong, 2 marks will go. Negative marking also will go. One question is wrong. 2 marks will go first of all. Negative marking also some more marks will go. I think 2.66 marks will go. 2.66 marks will go. One question is wrong. 2.66 will go. One question is right. 2 marks you will get. So you see the difference. One or two questions only difference. These three people are same batch people. Same batch people. One is 69, one is 66, one is 64. So please careful. Study properly. See, already mentioned complete graph. Complete graph. When you say complete means complete. When you say complete means full. Complete means full. Right. I think you got some idea. I want to give some idea. I give it. Now listen. It's a very, very interesting question. It's a very, very interesting question. Can you see this also? Can everyone see this one? Can you see this also? V1, V2, V3, V4, V1, V2, V3, V4, V1, V2, V3, V4. Everyone listen. Everyone listen. This graph contain how many vertices? This graph contain how many vertices? Please give answer. One more small story coming. One more small story coming. This graph contain how many vertices? Everyone respond. Everyone should respond. If you don't respond, you will feel bored. If you don't respond, you will not become active. Whether you like or not, you have to respond. When you keep on responding, you will become active. See, suppose that I don't respond. See, I will be like this. I will be like this. Then you will also feel don't good. When if I am lazy, you will also become lazy. If you are lazy, automatically your brain cannot take. So please be active. Please be active, everyone. Can you say this graph contain 4 vertices? Can you help me now? 4 vertex graph. Every vertex degree maximum how much? 4 vertex graph. Every vertex degree maximum how much? 4 vertex graph. Every vertex degree maximum how much? Remember simple graph. We are discussing simple graphs only. Simple graph don't have self loop. Simple graph don't have parallel edges. 4 vertex graph. 4 vertex graph. What is the maximum degree? 3 na? How 4 yaar? Are Aman, how 4? 4 vertex graph maximum degree is 3 na? Because one person adjacent to all other people. He cannot be adjacent himself. He cannot adjacent to himself. If at all he is adjacent to himself, self loop. We are discussing about only simple graph. We are discussing about only simple graph. Now listen. So V3 maximum degree is 3. Can you guess? Can you guess in the simple graph? In the simple graph, right? V3 vertex maximum degree is 3. Can you say minimum degree how much? In a simple graph, 4 vertices, what is the minimum degree possible for any vertex? Remember, it is not a complete graph. Simple graph. I am talking simple graph. I am talking simple graph. It is not a complete graph. Because of it is a simple graph, you can keep 0 also. So I think see this one. This person, right? I will keep minimum degree. Minimum degree means what? 0 degree. This person also I will keep minimum degree. This person also I will keep minimum degree. This person also I will keep minimum degree. What is the meaning? In the given simple graph, for every vertex, you are keeping minimum degree. That is called as 4 vertex null graph. That is called 4 vertex null graph. In the given simple graph, everywhere keep minimum degree. Everywhere, not one place, two place. Everywhere keep minimum degree. If you keep everywhere minimum degree, then I think what the answer? 4 vertex null graph. Name itself saying null graph. Null means nothing, means no edge. In the given simple graph, every person having 0 degree, then it is called null graph. It is a 4 vertex null graph. 4 vertex null graph. In the similar way, in the given simple graph, which contain 3 vertices, every person degree is 0. It is a 3 vertex null graph. It is a 3 vertex null graph. In the given simple graph, every vertex contain 0 degree. Every vertex contains 0 degree, but number of vertices are 2. It is a 2 vertex null graph. It is a 2 vertex null graph. It is a 2 vertex null graph. Next one. In the given graph, let me write now. I'm writing here. In the given, be careful. In the given simple graph. In the given simple graph, every vertex degree, each vertex degree 0. Then it is null graph. Then in the given simple graph, every vertex degree 0, then that graph is called null graph. Be careful. Now, one important question. Everyone listen. One very, very important question. Please give answer. I think you don't give the wrong answer now. Can you see the note? Note 1. In n vertex, see the answer. In n vertex, null graph. In n vertex null graph. Can you help me now? Minimum edges how many? In n vertex null graph, minimum edges how many? And maximum edges how many? I want answer from you. In n vertex null graph, minimum edges how many, maximum edges how many? I want answer from all of you. In n vertex null graph, minimum edges how many, maximum edges how many? It is a null, it is a null, it is a null. Graph is null graph. Null means no edge at all. If no edge, minimum edges also 0, maximum. It is a trap. In the similar way, can you see this one? In n vertex, complete graph. In n vertex complete graph, right? Maximum edges how many? Minimum edges how many? What is the answer? Because of it is a complete full. Complete means full. N vertices, every vertex degree is n minus 1 by 2. Because of complete, no maximum, no minimum. No maximum, no minimum. Is it okay? Are you comfortable with this? Are you comfortable with this? It's a very, very tricky question. Very, very tricky. These are very, very tricky. Please remember, not listening and leaving. Not listening and leaving. Remember. If anyone done mistake in the class, if you done the mistake, remember. You done some small mistake, remember. If you think that's ayo sir, chota galti happened. Ayo Reddy sir, small galti happened. If you think, remember, don't repeat. Remember, don't repeat. Now I am going to give one nice question. Can you see this one? I don't know how many people will give. Can you help me now? In n vertex, everyone listen. In n vertex, simple graph. In a n vertex simple graph, can you help me now? Maximum edges how many? Minimum edges how many? Can anyone help you now? Is it listen? N vertex, is it simple graph or null graph? I'm repeating once again. N vertex, is it simple graph or null graph or complete graph? What is the graph given? In the third point, what is given? In the third point, what is given? Null graph or complete graph or simple graph? In the third point, is he asking null graph or simple graph or complete graph? Which one? Simple graph. He is asking simple graph. Listen, in the given simple graph, he is asking maximum edges. Oh, simple graph can be anything. You want to keep maximum edges. If you want maximum edges, he is indirectly asking complete graph, n into n minus 1 by 2. He is not asking degree by he is asking edges. One more thing. When you say simple graph, it may be null graph, it may be complete graph. Because of he is asking minimum edges. Oh, null graph, 0. Because of maximum edges if you want a complete graph. Maximum edges if you want a complete graph. If you want minimum edges, null graph. Now it is a correct time to ask you. Please help me. Simple graphs. Can you help me now? Simple graphs are 2 types. Can you help me now? In all the simple graph, what is the minimal simple graph? Minimal simple graph is null graph. Minimal simple graph means less edges are null graph. Yes. Maximum simple graph is complete graph. Simple graphs are 2 types. Minimal simple graph is null graph. Maximal simple graph is complete graph. Are you okay with this? Simple graphs are 2 types. Everywhere keep minimum degree, null graph. Everywhere keep maximum degree, complete graph. Everywhere maximum degree. Everywhere maximum degree. Everywhere maximum degree, complete graph. Everywhere minimum degree. Everywhere minimum degree. Right? Null graph means everywhere minimum degree. Complete graph means everywhere maximum degree. Now it is a correct time to ask you. From today onwards, if anyone asks you, simple graphs are how many types? What is the answer? If anyone asks you from today onwards, simple graphs are how many types? How many types? Simple graphs are how many types? If anyone asks you, how many? Minimal simple graph is a null graph. Maximal simple graph is a complete graph. Minimal simple graph is a null graph. Maximal simple graph is going to be complete graph. But remember, simple graphs are many types. See, in between there are so many. In between there are so many. We are not discussing. Because anyhow, discrete mathematics, graph theory, we are going to discuss everything. Discrete mathematics, graph theory, we are going to discuss all. Whatever is necessary for this topic, let me discuss only that. Simple graphs are many types, but I written mainly, my concentration here, mainly two simple graph. Minimal simple graph, which is the null graph. Maximal simple graph, which is complete graph. In between, there are so many. In between, there are so many. You may say that, sir, what are those? In between, so many. What are those? There are some graphs are there. Cycle graph is there. Right? Wheel graph is there. There are so many. You no need to write also. Next one, regular graph is there. Next one, bipartite graph is there. You no need to write also. There are so many. Bipartite graph also there. Complete bipartite also there. Planar graph is there. Euler graph is there. Hamiltonian graph is there. There are so many. There are so many there. Hamiltonian, Euler graph also there. Euler graph, Hamiltonian also there. Next one, planar graph also there. You no need to bother. You no need to bother. So many graphs are there. I want to say so many graphs. You no need to write also. Planar graph, cycle graph, wheel graph, regular graph, bipartite graph, complete bipartite graph, Euler graph, Hamiltonian graph, planar graph, many. But we are discussing here only two main things. Minimal simple graph, null graph, maximal simple graph, complete graph. Now, last question I want to ask you. Please give the answer. N vertex simple graph. What is the maximum degree of any vertex? N vertex simple graph. What is the maximum degree of any vertex? I am asking maximum degree. I am asking maximum degree. In n vertex simple graph, maximum degree of any person, n minus 1. Minimum degree, 0. So in the given simple graph, everywhere keep minimum degree, null graph. Everywhere keep maximum degree, complete graph. Right? Fine. Now some people are asking, listen, interesting one. Everywhere if I keep minimum, null graph. Everywhere if I keep maximum, complete graph. Everywhere keep minimum, null graph. Everywhere keep maximum, complete graph. Can you help me? Everywhere minimum, null graph. Everywhere maximum, complete. But there may be a chance that few people minimum, few people maximum. Will you agree? There may be a chance that few vertices contain minimum degree, few vertices contain maximum degree. Am I right or not? Those will leads to these combinations. Maybe cycle graph, maybe wheel graph, maybe bipartite graph. Everywhere minimum null, everywhere maximum complete. But there may be other possibilities. Maybe I think out of 10 vertices, 5 may be null graph behavior. 5 may be complete graph behavior. There may be a chance. So in between there are many people. It is not the correct time, right? Because we are not doing graph theory here. We are doing graph basics because I want to do graph traversal, which needed all these things. Right? So I think from today onwards, if anyone asks you, simple graphs are how many types? Many types, but mainly there are two types. Many types, but mainly there are two types. What is the answer? Right? In the simple graph, minimal simple graph means Don't keep one edge also. Everywhere minimum degree, 0, 0, 0, 0, 0. Null graph. Everywhere keep maximum degree. Maximum, maximum, maximum. I think it is going to be complete graph. So these are the two extreme corners of graph theory. Graph theory contains two extreme corners. Minimal simple graph is a null graph. Maximal simple graph is a complete graph. Now, one small question I want to ask you. Please give this also. One small question I want to ask you. Please give this also. Everyone listen. Everyone listen. V1, V2, V3, V4. Yeah. Can anyone help me? Can anyone help me? What is the degree of first vertex? 2. What is the degree of V1 is 2. What about V2? 3. What about V3? 2. What about V4? 2. Can you help me now? Can you help me now? What is this? Is it sum of degrees? Is it sum of degrees? This person degree 2, this person degree 3, this person degree 2, this person degree 2. Can you help me? Is it sum of degrees? 2 plus 3 is? Yes. 2 plus 3 is 5. 5 plus 4 how much? Check if I done anything wrong. I think one person wrong. Right? Yeah, I'm changing. I'm changing. It is a 1. It is a 1. It is a 1. 2 plus 3 plus 1 plus 2. Can you say how much? Can you help in how much? Sum of degrees. Sum of degrees how much? 2 plus 3, 5. 5 plus 3, 8. Right? Can you help me now? Can you help me now? Interesting answer. Interesting answer. Listen, interesting answer. Whenever you are counting his degree, listen, whenever you are counting his degree, you counted this. Whenever you are counting his degree, you are counting this also. Same person counted 2 times. Sum of degrees, if you want, you can check, because of same person you are counting 2 times, it is going to be 2 into number of edges. Number of edges are, if you want, you can check 4. 2 into 4. Am I right? Number of edges are 4. Check. Number of edges are 4. Because the same edge you are counting it twice, sum of degrees became 2 into number of edges. 2 into number of edges. Let me write the formula. Let me write the formula. Sigma I is equal to 1 to n degree of Vi. I is equal to 1 means V1 degree. I is equal to 2 means V2 degree. I is equal to 3 means V3 degree. I is equal to 4 means V4 degree. Sum of degrees is equal to 2 into number of edges. This is called sum of degrees theorem. This is called sum of degrees theorem. So this is called sum of degrees theorem. And one more thing. Sum of degrees is 2 into E. Why 2 into E? Every edge counted 2 times. V1 also counting this edge. V2 also counting this one. Because of same person you are counting 2 times, double came. Can you say anything you can write 2 into something? Is it even number? Is it even number? Anything you can write 2 into something. So even number. Remember, sum of degrees is always even number. Sum of degrees is always even number. If you can write something in terms of 2 into something, that should be a even number. Sum of degrees is 2e, which is a even number. If it is sum of degrees is odd came, it means it is not a graph. Sum of degrees came odd, it is not a graph. In a simple graph, sum of degrees is always even number, which is 2 into e. Now, can anyone help you now? How to get the e value? Sum of degrees by 2 or not? Sum of degrees is equal to 2 into e. E is equal to 2 will come left side. Sum of degrees by 2, which is the number of edges. Will you agree? Will you agree? Sum of degrees is equal to 2 into e, where e is equal to 2 will come left side. Right? I will only for namesake I will do. Only for namesake I will do. Can you see this? V1, everyone listen, V1, V2, V3, V4, V5. Only for namesake. Only for namesake. Now one small question. Is it, listen, is it simple graph? One small question. Is it simple graph? One small question. Is it simple graph? Yes or no? Is it simple graph? Yes. Next one. It is a simple graph, okay. But you kept everywhere maximum degree. It is a simple graph, I am happy. You kept everywhere maximum degree, no. You kept everywhere minimum degree, no. It is neither simple, it is neither null graph nor complete graph. Will you agree? It is neither null graph nor complete graph. Will you agree? It is not complete. Please check. It is a simple graph. I can say only one thing. It is a simple graph. It is neither null graph nor complete graph also. Now, one small question, very, very important question. This theorem will work for complete graph or null graph or simple graph. This theorem is working for complete or null or simple graph. To whom this theorem will work? This theorem will work for every simple graph. Whether it is null, whether it is complete, whether it is something else, for every simple graph it will work. It may be null graph also, it will work. It may be complete graph also, it will work. Every simple graph it will work. E will work for every simple graph. Right? Now see this one. I taken one simple graph. Remember, it is not a null graph, it is not a complete graph, it is a simple graph. If you want, you can check. Is it working or not? One time check. Is it working or not? See, degree of this one 3. Degree of this one 3. Degree of this one 3. Degree of this one 2. Degree of this one 3. Sum of degrees add. 3 plus 3 plus 3 plus 3, 2. So sum of degrees, it should be always even number. Sum of degrees always even number. I think 4 3 is 12 plus 2 14. 14 can be written as 2 into 7. 14 can be written as 2 into 7. Can anyone help you now? Can anyone help you now? Is that 7 is number of edges, which is nothing but 2 into E? Is that 7 is number of edges? This is 14. 12 plus 2, 14. 14 can be written as 2 into 7. Is 7 is number of edges? Count there. 1, 2, 3, 4, 5, 6, 7. 7 edges. Number of edges are 7. Number of edges are 7. Remember this formula. This formula will work for every simple graph. It will work. Simple graph may be null graph. Simple graph may be complete graph. Every simple graph it will work. This is called sum of degrees theorem. This is called sum of degrees theorem. Sum of degrees is equal to 2 into E, which is even number. So where E is equal to sum of degrees by 2. Right? The sum of degrees 14 by 2 you do, which will become 7 become. Anyone having any objection in all these things, you can ask me. Anyone having any objection in all these things, let me know. From here I started. I started from here. Remember, simple graphs are 2 types. Many types, but as of now, we need only 2 types. Simple graphs are 2 types. Mainly 2 types. Minimal simple graph is null graph, where everywhere minimum degree. Right? Next one, maximum simple graph is a complete graph, everywhere maximum degree. But what about mixed? There are many graphs are there. We'll discuss in the discrete mathematics graph theory. Now come here. Sum of degrees, if you take the any simple graph, sum of degrees is equal to 2 into E, where E is the number of edges. Right? So this is the sum of degrees theorem. It will work for every simple graph. Because of you are writing 2 into E, which is an even number. So I given one example also. I hope everyone is comfortable. Now I am going to say one more small thing. Can you listen that also? I am going to say one more small thing. Can you listen that also? Please listen. I'm going to say one small thing. Everyone will listen that also. Everywhere will listen that also. Yeah. Everyone listen. Everyone listen. This is the homework. This is the homework. I'm expecting answer. Tomorrow I will give answer. Tomorrow I will give answer. Homework. How many? How many? It is a homework. How many simple graphs possible? How many simple graphs possible? How many simple graphs possible with n vertices? This is the homework. How many simple graphs possible with n vertices? How many simple graphs possible with n vertices? This is the homework. This is the homework. And one more thing, I will give these notes. I will keep these notes in the group also. I will keep these notes in the group also. Right? Group also I will keep. If anyone not there in the group, this is our WhatsApp number. You can please ping me. I will add you in the group. Please ping me. I will add you in the group. This is the WhatsApp number. You can please ping. We will add you in the WhatsApp group. In the WhatsApp group, I will keep these notes. If I keep it somewhere, you may miss it out. I will keep in the group. This is the homework. Please remember. Please remember this is the homework. And one more. Right? One more. Next week, next Saturday, Sunday. Understand. Next Saturday, Sunday. Right? Data structures. Next Saturday, Sunday. Data structures. Weekly test will be there. Maybe I think Saturday or Sunday data structure, right? One more days I'll go test. I'll go also going on. Data structures, right? Weekend test will be there. Not this Saturday, Sunday, next Saturday, Sunday. Data structures. So I'm writing that, right? I'm saying Sunday. Next Sunday, data structure test will be there. Weekend test, 7 p.m. to 8 p.m. 7 p.m. to 8 p.m. there is a data structure test. Please careful. Weekend test will be there. 25 questions. 25 questions will be there. Weekend test. Right? Be careful. Next Saturday, Sunday, right? There is a data structures weekend test. 25 questions. This is the homework to you. Tomorrow I will explain. This is a homework to you. Tomorrow I will explain. So please revise all of them. I want to say more, but tomorrow again some more people will come. Right? Otherwise they will miss out. Right? So from here onwards I started from here. So those people who came late, so please go through from here. From here onwards you study. From here onwards you will study. Tomorrow major story. BFT, DFT will start. Tomorrow major story. BFT, DFT will start. Right? And one more thing. Right? 60% offer is going on. 60% offer. If anyone is not joined, they can join now. We got approximately, right? So approximately, right, below 100 ranks. Approximately we got 40 people. We got 40 people approximately. Below 300, we got approximately 150 people. 150 people we got. 150 people we got. So if you see here, there is a 4th ranker, there is a 8th ranker, there is a 10th ranker. There is a 10th ranker, there is a 53, there is a 42. There are so many people are there. Right? If anyone not there in the WhatsApp group, please WhatsApp us. Right? Yeah. So anyone having any doubts, please let me know. Ready, sir? I have this doubt. If you have doubt, you can ask me, I will help. If you have any doubt, you can ask me. Someone is saying, will you teach a complete DS? No, right? Only 5 or 6 lectures will be here, Aman. 5 or 6 lectures will be here. Right? Someone is saying, should we try every possibility, sir? Should we try every possibility? Yeah, whatever you are thinking, you try. See how many simple graphs possible with n vertices. How many simple graphs possible with n vertices? That is the given one. Whatever you are thinking, you try. Tomorrow I will explain remaining thing. Tomorrow I will explain remaining thing. If you are serious about GATE examination, please start now. If you are serious, please start. Those people who are serious, if you start after some time, some people are asking, sir, if I start after some time, what is the problem? If you start after some time, 50% syllabus only you can complete, because there are 13 subjects. You have approximately 10 months or 11 months is there. There are 13 subjects. Approximately you have 11 months only. If you do the preparation after some time, only 50% syllabus you can complete. If you do after some time, you may complete only 80% syllabus. If you do after some time, you may complete 100% syllabus, but you may not able to do practice. So if you want to do syllabus completion, practice also, please start now. Anyone not done, please start now. My sincere request, please start now. You want to write GATE exam, please start now. You don't want to write, please get out. You don't want to write, please get out. You want to write, start now. It is my humble request. Afterwards, don't blame me. Reddy sir, I completed 50% syllabus. Reddy sir, I completed 80% syllabus. Reddy sir, I completed 100% syllabus. I'm not written the test series. What should I do? These are the serious implications. Please start working from now onwards. Every weekend write the tests also. Then only you will get the rank. Suddenly you don't get the rank. Please start now. Every weekend write the test. See, data structure is going on. Some people are completing algorithm. Some people are completing TOC. Some people are completing that DLD. Some people are completing. One batch is DLD going on. One batch TOC going on. One batch algorithm going on. Right? One batch is discrete mathematics is going on. Very soon, mathematics also going to start. So if you do more work, you can complete the syllabus faster. If you do more work, you can complete the syllabus faster. Please careful. Do more work. If you do more work now, you will complete the syllabus faster. You can do a lot of practice at the end. If anyone is not joined, go to exampreptool.com. From there, if at all GATE CSE you want to join GATE CSE. GATE DA you want to join GATE DA. Whichever you want to select. Right? So let me know if anyone having any objection. Little doubt also there. So I given WhatsApp number also. There is a WhatsApp number. You please ping me. You can ask whatever doubt you have. Reddy sir, I have this doubt. Little doubt also there. Don't join. Right? Confirm from me. So, Reddy sir, I have this doubt. Right? What should I do? I have this doubt. What should I do? Right? So I will help you. Right? I will solve. Serious, then only start. Not serious, just leave it. Right, fine. So we'll see, right, in the tomorrow's class. I will give some more assignments. I will give in the tomorrow's class. Okay, fine. So can we stop now? Few days go 1 hour. Right? After 5 lectures are over, then we will go to more faster. After 5 lectures are over, we will go more faster. Tomorrow morning, there is no algo class. Sunday is there. So tomorrow morning, there is no algo class. Right? But DS class is there. Tomorrow morning, there is a DS class is there. Right. Perfect then. Thanks everyone. Shikhar, good night. Abhishek, good night. Rinkan, good night. Good night, everyone. Good night. Start, right? 3 subjects. Start 3 subjects. Right? Morning 1, afternoon 1, evening 1. Start 3 subjects. Morning 1 subject, afternoon 1 subject, evening 1 subject. Right? You can go for recording also. You can come live also. It is up to you. right? Morning algo is going on. Tomorrow morning no class. Monday onwards classes are there. Monday onwards algorithm will be there. Data structure tomorrow also there. Data structure tomorrow also there. Tomorrow morning not there. Rincon tomorrow morning not there. Chalo then. Good night. Good night. Bye everyone. Bye. And one more, these notes also I am posting. These notes also I am posting in the group. In the group I will post these notes. In the group I will post these notes. Chalo.